Hi children, good morning. How are you? How is your classes going on? Are you watching the videos? Very good children. So, welcome back to our session. What is our topic going on? Light, reflection and refraction. In the last class, we have learnt about the refraction of light and the definition, is it? And also, through a small video, we have learned about how to draw the refraction of a light through the glass slab. Is it? Yes. So let me learn about the laws of refraction of light. Already we have learned the laws of reflection of light. Is it? Two laws. Here also we are having the laws of refraction of light. Let me see what is that. The incident ray, the refracted ray and the normal. So, incident ray, which is coming from the object, that is maybe the sun or the light. That ray we call it as the incident ray. Refracted ray, which it is going to refract from the incident ray, which it is going to refract for us. We call it as the refracted ray, and the normal ray, which it is having. That means, if you think this is the mirror, this is the incident ray, this is the refracted ray, which you are going to draw the middle, that is the 90 degree, we call it as the normal ray. To the interface of two transparent media at the point of incident all lie on the same line. So, this two transparent media at the point of the incidence, all it is going to lie on the same plane. Next, second one. The ratio of the sine of angle of incidence to the sine of angle of reflection to the sine of angle of refraction is constant. So, sine of angle of incidence is going to denote by the letter as I. Then, sine of angle of refraction is going to denote by the letter as small r is constant for the light of a given color and for the given pair of the media. So, both are also will be the constant when for the light of the given color and for the given pair of the media. This second point is also known as, very important children, Snell's law of refraction. So, here the two types of the questions we can ask, or in the examination also it is going to occur. State the two laws of refraction of light, or state the Snell's law of refraction. So, the second point of this law of refraction of the light is nothing but the Snell's law of refraction, or easily you can say that sine I. What is sine I? Sine of angle of the incident, angle of the incidence by what is R? Sine angle of the refraction. So, this sine I by sine R is equal to constant. What does this denotes? It denotes the Snell's law of the refraction. Okay? Next. So, sine I by sine R is equal to constant. This is called as the Snell's law of refraction. Is it? Then what do you mean by constant? Constant value is called as the refractive index. What do we call? Constant value is called as the refractive index. Okay. So, let me know about the refractive index in the next class. So, until that, carry on the two laws of refraction of light. Is it? Okay? Thank you. Thank you very much.
Of light. You would have probably noticed that a spoon placed in a glass of water looks bent at the surface of water when viewed obliquely. The print on a page appears to be raised when the book is held behind a glass bottle filled with water. All these are the tricks of light. We shall explore how a light ray travels from one optical medium into another. You will need a glass of water, milk, pencil, a torch, aluminium foil, elastic band, needle. First, you need to prepare a point source of light. Observe how the torch is adapted as a point source of light. Here you've the point source of light. To give a cloudy effect for the glass of water, add a little milk to water. Darken the room. Shine the ray of light from the torch to the bottom of the glass. Observe the path of the ray of light. The path is crooked. This shows that a ray of light changes its direction of propagation as it travels from air to water. Similarly, a pencil which is partially dipped in water appears bent or broken to the observer. When a ray of light passes from air to water, its speed changes. Due to this, there is a change in direction of the ray. This change of direction suffered by a ray of light as it passes obliquely from one optical medium to another optical medium with different optical densities is known as refraction. Note that whenever a ray of light is incident on a surface separating two media, a small fraction of the light always gets reflected. Refraction can make an object appear to be in a different position. For the same reason, the part of the pencil which is submerged looks as if it has moved away from the part above water, and it appears fatter. Now, let's understand the phenomenon of refraction by studying the ray diagrams. Whenever a ray of light is traveling from a rarer medium to a denser medium, the refracted ray bends towards the normal. Here, IO is the incident ray, OR is the refracted ray, I is the angle of incidence, and R is the angle of refraction. In this case, angle I greater than angle R. If the ray of light is traveling from a denser medium to a rarer medium, the refracted ray bends away from the normal. Here, IO is the incident ray, OR is the refracted ray, I is the angle of incidence, and R is the angle of refraction. In this case, angle I less than angle R. For definitions, click on the labels. The ray of light striking the surface of separation of the media through which it is traveling is known as the incident ray. The perpendicular drawn to the surface of separation at the point of incidence is the angle which the incident ray makes with the normal at the point of incidence. The angle which the refracted ray makes with the normal at the point of the ray of light that has changed its direction at the surface of the ability to refract light is called the refractive index. Refractive index of a medium is equal to the ratio of the speed of light in vacuum or air to the speed of light in that particular medium. Refractive index is equal to speed of light in vacuum by speed of light in the medium. This ratio is always a constant for a given pair of media. It is represented by a Greek letter mu. Here are some of the effects of refraction. A straight pencil, PQ, when immersed obliquely in water, a portion of it appears to be shortened and raised up as P1, Q1 under the water. Let us understand this with the help of a ray diagram. Rays of light from the point Q are traveling from water to air. As the rays of light are traveling from a denser medium to a rarer medium, they bend away from the normal. After refraction at the surface, they appear to be coming from point Q1, which is true for each and every point of the part of the pencil which is immersed in the water. During spear fishing, the fisherman aims at the tail of the fish. When a fish in clear water is viewed from an angle, its image appears ahead of its actual position, as it is raised up due to refraction of light from water to air. Thus, if the fisherman aims at the head of the image of the fish, the spear will hit in front of the actual fish. However, if the aim is at the tail of the image, it is likely to hit on the head of actual fish. Go through the ray diagram to understand this. Twinkle, twinkle, little star. That's what we were taught. But do they really twinkle? No, stars do not twinkle. Let us now learn about why they appear to do so. The rays of light coming from the stars travel through the layers of air of varying densities. These rays get refracted continuously, and they bend towards the normal as the refraction is from a rarer to a denser medium. The movements of air and convection currents causes a change in the density of the layers of air. As a result, the position of the image of the star goes on changing after every short interval. These different positions of the images formed at short intervals of time give the impression that the star is twinkling. At dusk or dawn, the sun appears to be larger than at noon. This is because when the sun is near the horizon, the rays of light coming from the sun have to pass through layers of air of increasing density. Due to continuous bending of light, the sun appears to be larger. At noon, the sun appears to be smaller than at dusk or dawn. This is because the rays of light that fall normally on the surface of the earth do not get refracted.